welcome back. We know how to create superposition using the Hadamard gate. But superposition alone isn't enough to make a quantum computer fast. To get the right answer out of millions of possibilities, we need quantum interference. Today, we'll see how waves of probability interact to hide wrong answers and amplify the right one.
Think of wave interference in physics. When two peaks meet, they combine into a bigger wave, constructive interference. When a peak and a trough meet, they cancel each other out, destructive interference.
Quantum states behave the same way. By applying specific sequences of gates, like running two Hadamard gates, back-to-back opening parenthesis Qc.H0, followed by another Qc.H0, we can make quantum paths interfere.
Let's see what happens in code. If we start with a qubit, put it into superposition with Qc.H0, and then apply another Hadamard gate Qc.H0, something amazing happens. Because the Hadamard gate is its own inverse. The second gate causes destructive interference for the one state and constructive interference for the zero state.
When you run and measure this circuit, you get 100% of the time on a simulator. The wrong path completely canceled itself out through interference.
To summarize, quantum interference is how we manipulate probabilities amplifying correct solutions while destroying incorrect ones. In part 4, we'll combine superposition, entanglement, and interference to build the famous C-naught gate and Bell states via code.
Interference is the core reason why quantum computers can provide exponential speed-ups. Without it, checking a superposition of states would just give you a random, useless result when measured.